This talk is on Rack Middleware, and to set the mood appropriately, I would like to point out that a great abbreviation for middleware is actually the combination of a lowercase w and a lowercase m, also giving the rock sign. And we should also start out by killing the silly title of this presentation, in a world of middleware, who needs monolithic applications? Obviously no one needs a monolithic app. That's actually pretty bad. The real key is choice, and we have more of that in the Ruby world today than we've had in the past. And the more we learn, the more kinds of cool abstractions that we're able to build. And I think in our community, we do a good job of pacing that correctly. I don't think that we build out architecture prematurely. I think Rack is a very good example of that. So I hope to share some of those things with you today. As a brief matter of introduction, my name is John Crosby, and if you'd like to get in touch with me, you can use my site. I'm the author of CloudKit, which you can also check out at this site. Also a contributor to the RackContrib project on GitHub. Both of these projects I mentioned because they contain examples of the types of things that we'll be discussing today. I'm newly an employee of EngineYard, and specifically I work on our new Solo offering. It's the on-demand platform for Rails applications in the cloud, and it actually goes beyond Rails applications. You can use MERB apps, which will soon be Rails apps, Rack apps, and basically anything that you would want to put on your own instance. You have a high degree of control and automation on the platform. I do come bearing gifts today as well. You may have already read about on the blog, but during the entire conference and the Hackfest, we are offering the Solo platform for free. So if you haven't already received a postcard, find one of the EngineYard people, and we'll give you a card with a code to use the platform free during the entire conference. And if you should decide to sign up for a paid account, what?
Tonight at Hacking Suite.
Okay. Come to the Hackfest, and we'll give you the cards there. If you do decide to sign up for a paid account before the end of the month, we'll give you a discount on sign up as well. So getting right into the subject matter here, do you remember CGI? Or more specifically, do you remember building something like this, app.cgi? I will admit to building something like this in a previous life. I'd like to show you an excellent example first with a health warning. The following slide does contain some Perl. And not just any kind of Perl. It's actually old school Perl CGI. And this example is especially cool because I found this online in a real tutorial teaching someone to write Perl using the CGI Perl module. So check this out. We're coming into this code, I guess I'll call it, and we're checking for a parameter. And if you're a Rails user, you're already cringing because you're familiar with the concepts of REST and having nouns in your URLs. And we have this action parameter, as if the HTTP methods aren't good enough. And we're checking for some arbitrary all string. And if we find that, we're building up some SQL. And then we're using the low-level SQL library right here in place. Select all array ref. If we find any sort of rows, then we're building up our table structure right here. And we even have styling information smashed in the same bit of code. So I think this demonstrates the way that maybe some of us learn to write apps when we're just sort of feeling around. Perl was actually the first language that I personally used, and so I wrote a mess like this at one time. And that's what we call a monolith. Monoliths are bad. So today we have things better, of course. We have Rails, and we have a nice clean separation between models, views, and controllers. And it goes beyond that. We've got nice abstractions and active record for callbacks. Rails, of course, isn't the only game in town. There's a lot of other great frameworks providing elegant abstractions. However, I think that the more we build these types of apps, the more we'll realize that we're also cramming things into places that could be pulled out and abstracted in new ways. And the more we build, the more we'll learn. Authentication is a clear example of something that could be pulled out. And specifically, single sign-on is another great candidate for this. Caching as well is something that we could pull out of our apps. There's actually very good reason, of course, to do partial page caching within an app where you need to have access to logic about specific components on your page. However, coarse grain caching, where you're caching documents with e-tags and last modified, can definitely be pulled out of our apps. So just to look at the current state of affairs, with an authentication example using OpenID and OAuth combined, which I hope to see more of in the wild. If I'm running a Rails app, this could be any sort of app, but I would typically have to install 2 different plugins, maybe one for OpenID, one for OAuth, and I'm going to need to generate some controllers for sessions or what have you, generate models for users, possibly user roles. These will entail migrations which need to be run. Perhaps if I'm installing plugin number 2, I need to modify the session controller I just generated for plugin number 1. And in the worst case, I'm possibly monkey patching the Rails stack in some way I'll regret later on. This is also sad. So we can take some lessons from the web itself. Looking at the architecture of the web, we have HTTP that comes in to the front of our stack. We have 0 or more intermediaries. These could be proxies, firewalls, caching servers, whatever. And then finally, we have an app at the end of the chain. And most of our time is spent working in this last app section here. And that's where Rack comes into play. And the architecture of Rack will look very familiar. This is a Rack app. HTTP comes in at the front of the stack. It passes through 0 or more intermediaries. In Rack, we call these middleware. And finally, there's an app at the end. So we can draw from this that Rack is the web, and related, the web is Rack. There's your free philosophy lesson for this morning. Rack is based on WSGI, which is a standard that came out of the Python community. And WSGI is a little bit more detailed, possibly more rigid than Rack. But that stands for the Web Server Gateway Interface. And the idea was to provide a thin abstraction layer between web frameworks and web servers. That way people didn't have to write a new adapter for their framework every time some new server came out, like Thin, Mongrel, etc. So Rack took the same sort of an idea in a simplified approach and ran with it. And it's just called the spec. There's no acronym. So here's a basic Rack app. Rack apps are Ruby objects that respond to call. So in this case, a Lambda will do just fine. They take exactly one argument, and that is the environment, which we'll look at in detail in a moment. And then they're required to return an array of exactly 3 items. The first is a status code. So here we're using 200 for HTTP success. The second parameter is a hash, and it's a set of key value pairs that map to the headers that you want to return in your response. And finally, the response body, which must respond to each. So in this case, I've just dropped a string in here in an array. Now to run this, Rack is very cool. We can just type run. We can drop this into a file called config.ru, which stands for Rackup. Use Rack's built-in utility called Rackup to run this file. And then if we hit this with curl using Rack's default port, we'll see that we get the response hello. Now, you don't, of course, have to use Lambdas to write your apps, and as a matter of fact, you probably won't as your apps grow. You can just write a class with a call method, and that will accomplish the same task. To see all the details about what's required in the environment, you can run rake spec if you've cloned the Rack project, and you can see in great detail everything that it's requiring. And actually, when you run Rack up in development mode, RackLint is inserted as a piece of middleware that will check you. And that is very good to run that at all times during development to make sure that apps or middleware that you're creating are compliant with the spec. So, as I mentioned, the RackLint and the spec are focused on this environment that gets passed in. And that includes lots of items of interest. One is the request method. So if I access this environment hash within my app, ask for the request method, I would get what you would expect to see, whatever HTTP method was coming in. Path info just gives you the path to whatever they're requesting. There are also HTTP style header params. So if someone sets an accept header, it will come in and look like this. For example, requesting a JSON document. There's also a group of Rack namespaced protected keys in the environment. And if you're building your own apps, I would suggest staying out of this for safety and to comply with the spec as it stands today at least. One of the most interesting is probably Rack input, which is the input stream. So if I lob a bit of JSON to my app, and it's not actually a parameter, but it's just a post of some JSON, then I can use rack input, which is required by lint to respond to gets, each, read, or rewind. I can get the content of that. And you can also create your own namespaces within the environment. And this is useful in the case that your apps need to work together and you need to drop something in the environment that can't be spoofed externally. So if you try to set something like X remote user as an environment variable that you're trusting downstream, I could easily spoof that in the browser, because if I set that header in Firefox or Firebug or whatever, then Rack will just pass that straight on through. So if you need a way to know that this came from something internal that you've created, put it in your own namespace and drop it in the environment. And if you don't like working with raw hashes, and you'll probably outgrow those at some point, then you can wrap the environment in a request object and get things that you're more familiar with from OO land, like rip request post, what was the param called ID, and you can also check incoming headers. If you're checking for an e-tag match, this is how you would check what the value of that is using the environment. So now, moving into middleware, it's everything in front of our app, as we saw earlier. And to set up this particular diagram in a Rackup file, we actually just say use middleware A, B, and C. It stacks those up in front of the app, and then finally we run the app at the end. So this is the world's worst piece of middleware. This is called Go Slower, and just to demonstrate how middleware works. The first rack is on startup. When you call Rackup, it's going to initialize this middleware, and it passes in the app. The app might be the app at the end of the stack, but you should think of it as the next thing in the stack, technically. So we have an opportunity to save that here. And then on every request, Rack will call your middleware, passing in the environment. Here, we stupidly sleep for 1 second because our app was too fast. And then finally, we call down to the next thing downstream. Now, this is where all the power of the middleware comes in, is this line right here. Because we're actually returning the result of app call, which is the result of everything that came back from downstream. We have access to the environment before we get into this call, and we have access to modify that environment coming back out of the call. So everything that you do in a piece of middleware occurs right around this spot. And you can see lots of examples of people implementing self-contained pieces of middleware in the Rack Contrib project. Just to highlight a few, there's one called Rack Profiler. You can drop that in a Rack app and actually, of course, do profiling. There's one for mail exceptions. This is something that's often implemented in plugins, but using Rack, it can catch any exception that's thrown and provide you with an email that's got the call stack and the exception, things like that. There's one for JSON-P. So in an abstract manner, you can basically do the padding and the removal of the padding in and out of your app just with a piece of middleware setting in front of it. And a new addition to this project, which is kind of interesting, Rack CSS HTTP request. So if you've heard of cross-domain JSON-P being used before, there's some security questions around it, and more conservative types would probably implement that using a proxy on their own domain. However, with CSS HTTP requests, you can actually request read-only data from another web service, and this piece of middleware will encode it as CSS, embedding an array of CSS classes with data elements that have the data that you're requesting from an external service. It's interesting. You should check it out. Also, outside of the Rack Contrib project, this is probably large enough to stand on its own. It's Rack Cache. Highly recommend looking into how that works for adopting good caching practices prior to investing in the infrastructure it would take to have like Varnish or something like that sitting in front of your app. And finally, one of the ones that looks most ridiculous in the Rack Contrib project is Rack Not Found. I'm guilty of writing that one. And it does just what you expect. It returns a 404. And while this might seem sort of silly, if you think about it, we've got this stack that's calling through a bunch of middleware, and it finally hits an app at the end. And here's our setup as we saw earlier. And if apps look like this, they take a call and they return something, and middleware looks like this, the only difference being it knows the thing that's downstream from it, then what's the point of really having an app at the end of our chain, right? So, got some heckling from the back there. So, now look at our diagram, sort of brushing off the app at the end of the chain. we can talk about what I call cooperative middleware at this point. Cooperative middleware takes a look at the URI space, which if you're building a typical Rails app, for example, your URI space is everything. If it doesn't match a route that you've defined, you catch it and do something else. Whereas in cooperative middleware, your URI space is only what you need for the thing that you're building. So as an example, we'll take CloudKit. I'm not here to give a commercial about that today. I'm just going to tell you only what you need to understand the next part. But CloudKit is an open web JSON appliance and allows you to do things like this. In a Rackup file, I can say expose notes and to-dos. And what that'll do is mount a RESTful resource collection for notes and to-dos. And it supports all the operations you would expect from a true REST application. You can discover what resources are hosted here. You can discover using the options verb what methods are available to you, and then you can control those. It happens to store everything on the back end using Tokyo Cabinet, which is sort of fast. If you change the word expose to contain, then it also puts in front of your app an authentication filter for OAuth, and also one that cooperates with that for OpenID. So behind the scenes, it's actually building this up in RackBuilder. It's putting a session pool in front of it, dropping in the two filters I just mentioned, and then setting up the service. So as you can see, has the notes and to-dos resources there. If you happen to have an app at the end of the stack, it'll delegate to that. If you don't, it actually drops in its own 404 app, or if you're in development mode, it shows you a developer page. So the OAuth filter, following this example of just claiming only what URI space you actually need, will look at everything that comes in under /OAuth. The OpenID filter does the same thing. It just interacts with what you would expect looking at the OpenID specs. And then the service, of course, only cares about notes and to-dos. Things that don't match that are just passed down the stack. But this brings up new questions of how these pieces can cooperate. So here's an example of a browser coming in to access this service in CloudKit. It's going to hit the OAuth filter first, and of course it's going to fail because browsers don't yet support OAuth. I hope that changes sometime. But the OAuth filter, since it also supports a draft spec called OAuth Discovery, it knows how to set challenge headers for OAuth clients. So it drops that into the environment. The OpenID filter then, of course, fails because we haven't logged in yet. And what ends up being rendered for the browser is a login page that has challenge headers. So unlike basic auth, where if your browser gets a challenge header, it pops up this nasty gray box that no one likes to use, it just ignores it because it doesn't know what to do with it. So your browser can come back in, fail again on OAuth, go into the OpenID thing. Hopefully you can log in successfully with your provider, passes through to the service, and everything's good. Different scenario. Web services talking to each other using OAuth to sign the requests, or desktop apps doing the same thing. They'll hit the OAuth filter. They'll fail because they haven't done the OAuth dance. Challenge headers go in. OpenID fails. Same thing gets rendered. But if you're using service-to-service interaction or desktops looking at this, they don't care about the actual display of a login page on a web app, but they do understand these challenge headers. So they can then return, do the OAuth dance, get the request token, authorize it, get the access token, then pass the OAuth filter. The OpenID filter can pass on through. And finally, they get what they're looking for in the service. So what this requires is for middleware to sort of announce its presence in the stack, and this problem has actually been solved for us long ago using HTTP. So if you have a stack of proxies in front of a web app, they can set what are called VIA headers. And just as an example, straight from the HTTP spec, if we had a proxy server called Ricky that supported HTTP 1.0, and then one called Ethel and Fred, we would actually see this in a VIA header once we got to our app. It's great for debugging, but we can actually steal some of this for Rack middleware. It's not a good idea to actually use the headers because we're not stepping inside and outside of the HTTP protocol. So we don't want to make things confusing for something else that might be downstream later. But here, CloudKit is using its own namespace, setting that environment, that authentication is actually turned on for this app. That way the service knows that it needs to be monitoring what access people have to what bits. And then there's actually a pseudo VIA array that's in the app. So it's announcing that OAuth is present upstream and also OpenID. So specifically this OpenID filter that we saw can change its behavior based on what it expects. And for authenticated users, we drop the user in the environment right here. And instead of being a database ID, since we're using OpenID, we use IDs from the internet, which are URLs. Now, there are other alternative stacks that we can build up as well. There's one included in Rack called Rackmap. This one's pretty cool because you can actually build, for example, if you're building a blog, you could build 2 Rack apps. One that's the public blog that people use, and maybe one that's more of a database administration console. And it's a good idea to build 2 apps in this case, I feel, because that saves you from having to case around specific things like if someone's an admin or if they don't have this role, then don't show this link and protect this sort of thing. You could just actually drop some auth in front of this DB URI here. So we're mapping the root URL to the public blog. Anything under /DB will hit this database admin app. We can also use Rackmap plus Sinatra to build up some interesting combinations. Here's a Sinatra app. This is based on the very latest version of Sinatra, so if you haven't upgraded to 0.9.1, this is actually worth it just for this feature. There's your typical routing that is popular with Sinatra, get/do, show an index. And we're requiring Sinatra base, which is sort of a new thing, and we're extending a class called Sinatra base. The traditional way of building a Sinatra app is to require Sinatra, and this is for the old school app that uses everything for its URI space. But with this newer release of Sinatra, if you just require base and then extend that in your class, then you get this minimal Sinatra routing that everyone loves, plus you get the rendering helpers, the ability to say ERB index, for example, and it is middleware. So now we can actually say, use my Sinatra app in this stack and then run some other app. And we can embed that, of course, using Rackmap to a bunch of different Sinatra apps. There's also Rack Cascade. This one I haven't seen used a lot. It might be because it's a performance problem. But you can actually build 2 apps in the traditional sense of the word. And then if you set up a cascade in your Rack file, it will actually try each app to see which one doesn't. The first one that doesn't reply, basically with the 404, is the one that gets the response turned to the client. And you can also customize those status codes. Also, another interesting combo, Sinatra as middleware in a Rails application. If we created something like the middleware we saw earlier, this class X, I used to have a friend back in St. Louis that listened to the hip hop station. I'm not really a fan, but the DJs were always asking if they could get a what. And so I thought I could help them out here by writing a piece of middleware for this. So this middleware simply looks for the URI what and returns what. And in the latest environment file for Rails, you can actually set it up like this, config use middleware X. And you've got your entire Rails stack you already had, but you also have a what. So also, we should ask, can you use CloudKid in Rails? Yes, you can. Inside your configuration block in the new environment files, this is all, of course, Rails 2.3, you can say use middleware and just pull up this collection. So now what we have is a Rails app like you would typically build, but we also have this API that just got thrown in magically with no code generation, controllers, models, etc. That's backed by Tokyo Cabinet, used in the same app. So looking back at our architecture diagram, where we're sort of forgetting about these apps behind them, if Rails were to say not use the entire URI space, but pass to something downstream, perhaps Rack is inserting a 404 at the end, or Rails itself, if it doesn't see anything else, then you can imagine building applications that are built of maybe a Rails app that then passes through to, say, a MERB app or anything else that you might create. And what this gives us is a new unit of composition, which you might call an application, but hopefully after today you might see as middleware. So that's all I have, but we do have some time for some questions. Maybe we'll cut them a little short to catch up on some of our other lost time. All right, yes?
So you're working with a global URI namespace. How do you handle collisions, or how do you detect collisions between multiple middleware using the same URI?
Yeah, there's nothing available. Well, the question, for everyone's sake, is how do you detect collisions in URI namespace? And that question has not been answered. There's nothing in the Rack spec for it, which is purposely very minimal. And so we're at 0.9 with Rack at the moment. And I think on our way to 1.0, this is a good time to actually come up with some ideas for that type of thing. and propose them to go in the 1.0 spec. If they don't make the 1.0 spec, the mailing list is pretty active and the community is really great. So I would say if you have some ideas around that, definitely throw them out there. Any others? I can't see that middle back half because of the light.
Please repeat it as well.
I will. All right. Those are all the hands I see. Oh, no, one more. Yes?
So using for authentication or authorization of your app, that you have different segments of your app that might not require authentication.
Yes.
You know, I know that you just added a feature of that to CloudKit. Could you explain how you did those mappings? How did you selectively pass through in middleware?
Yeah, I hope I remember correctly, but the question was, how do you selectively determine which parts of your app require authentication or which parts don't? So he also realized that CloudKit just added a feature to do just that. Right now, I don't know if it's the best implementation. I like to see some other ideas from others, but in CloudKit, when you set up your OpenID filter, you can actually provide it an argument, which you can do with any piece of middleware that'll get passed in, for example, an options hash to your middleware. So in CloudKit, you can say, I want to authenticate everything except this list of URIs, and it will bypass those for you. There's probably a more elegant way to do that, and I think as Rails builds out on top of the Rack stack and we have more real-world apps being built there, something more appropriate might be formed. Yes?
Can't you put middleware inside the, go back a few slides of your database, your blog example?
Yeah.
Yeah.
There, yeah.
I'm pretty sure you can put middleware above like run blog db admin.
That's absolutely correct.
It just blocks out
Yes.
the /db.
Yeah, and I would recommend doing that. If you have an admin interface, the question was, can't you just drop a piece of middleware with authentication in front of the DB admin? And that's absolutely correct, and that would be the appropriate thing to do. Any others? Yehuda.
I would also just say that in addition to this rather simple map thing, we're also working on making the Rails and Merv router available as a middleware kind of thing. So eventually you'll basically have all the power of a real router at the middleware.
Yeah, so for those who couldn't hear, Yehuda was basically stating that in Rails and Merv, right now they're building a router that's a piece of middleware that everyone can share. So I know that there's been lots of discussion on nested params, parsing the most efficient way to do that. I think something really cool will come out of that that any Rack-based app can use. Any other questions? All right, that's all I see. Thank you very much.